Good morning. Today we are going to continue the chapter 3, System of Linear Equations by Gauss Seidel iteration methods. Okay, to use the Gauss Seidel iteration methods, okay, metric A must be diagonally dominant, okay, such that modulus AII is greater than summation of modulus AIJ, where the I from 1, 2, 3 up to n. Okay, for an example of system of 3 by 3 system. Okay, you have to make sure A11 modulus A11 is greater than A12 plus modulus A13, and secondly, you have to make sure that modulus A22 is greater than summation of magnitude A21 plus magnitude A23, and you have to make sure that magnitude A33 is greater than magnitude A31 plus magnitude A32. Okay, after you make sure that A is diagonally dominant, then you can write down the iterative formula such that you want to solve for x1. Solve for x1. The other two variables you bring to the other side. So your b1 minus a12 x2. Okay. K is actually the iteration step. K start from 0. Okay, 1, 2, and so on. So mean K, when we start with the initial guess x2 nodes, x3 nodes, okay, then we get x1, 1, with x1 at step number 1. Okay, so how to write? Okay, x1 actually will be b1 minus a12 x2 minus a13 x3 divided by coefficient of x1, which is a11. Okay, k here means okay, we start with initial guess. When k is 0, we get x1 at step 1. Similarly, you can solve for solve for x2. Solve for x2. So in this case, x2 will be b2 minus a21 x1 minus a23 x3 divided by a22. Okay, divided by a22. And then k mean with why is a k plus 1? This is k. Yeah? So mean just now k equal to 0. Initially we start with k equal to 0. So x3 at initial value, x1 because you obtained the new x1 already. So x1 k plus 1. So this is x1 number 1. When k is 0, to calculate x2 at step number 1, we still use we don't have the new x value, new x3 value yet. So x3 is still old value, which is x3 at step 0. x1 because you calculate here already. So x1 you take the latest, then you can get x2 at step number 1. Later on, you can x3 at step number 1. So you want to solve for x3. x3 will be b3 minus a31 x1 minus a32 x2 divided by a33. Okay, since k you have get the new x1 from here, new x2 from here. So x1 and x2 taking the latest value. So this is a Gauss Seidel iterative method. If x2 here, x1 you still take the old one. Okay, in here x1 let's say you take at k, x2 you take at k. This is called as Jacobian method. And the iteration is repeated with initial guess. We're starting with the initial guess, mean okay, x0 will take 0, 0, 0 transpose. 0, 0 transpose. Okay, x actually should be a vector, so we write in. Also will be the transpose here. So until the stopping criteria, which is maximum of magnitude ak plus 1 minus xk, and so xk plus 1 minus xk less than epsilon is satisfied. Okay, when you take the x actually consists of x1, x2, x3. You take the last row minus the previous row, that magnitude must all less than epsilon. Example 1. Show that matrix A 6, -1, 2, 1, -3, 1, 2, 5, 8 is diagonally dominant. Okay. So to show it, okay, so magnitude A11, which is 6. So it's greater than magnitude -1 plus magnitude 2, which is 3. So 6 is true greater than 3. You take this one. 6 greater than, this one when I take magnitude is 1 plus 2 is 3. Later on, magnitude A22, take this magnitude, you get 3, which is greater than, okay, greater than, this is 1 plus 1, 2, which is 2. And when you take this magnitude 3 is greater than 1 plus 1, 2. Okay, magnitude A33, you get 8 is greater than here, 2 plus 5, which is 7. Okay, hence A is diagonally dominant. Okay, second example, show that A equal to 6, -1, 2, 1, -2, 1, 4, 5, 8 is not diagonally dominant. Okay, against magnitude A11 is 6. Okay, and then this is greater than magnitude -1 plus 2, 3. Now you see magnitude A22, you get 2. Now this one, take the magnitude, you have 2. Okay, this is equal to 1 plus 1 equal to 2, not greater. Okay, to show it's diagonally dominant, make sure okay, magnitude A22 greater than magnitude A21 plus A23. Okay, against magnitude A33, you get 8. Okay, 8. This is less than 4 plus 5. So this one, this one is fair. 8 is not greater than 9, of course. So that's why A is not diagonally dominant. Because diagonally dominant, make sure the magnitude A33 is greater than the summation of the other two values. So that's why this is not diagonally dominant. Example 3, arrange the equation so that matrix A equal to 1, 5, 2, 1, -2, 8, 4, 1, 2 is diagonally dominant. Okay, first of all, if you observe this one, means magnitude A11 is equal to 1. Okay, it's actually less than 5 plus 2. So we must, okay, this one is less than, not greater than. And then you look at magnitude A22, which is 2, also less than, here, magnitude here is 2, less than 1 plus 8. Okay, magnitude A33 is 2, also less than 4 plus 1. Okay. Diagonally dominant, we must want all this one. Okay, diagonal must be AII greater than summation of your AIJ. Okay, you want summation of AIJ mean here. You look at the magnitude here, the diagonal. Make sure the magnitude of the diagonal is greater than summation of the other 2 and 3. Okay, and then how to rearrange so that matrix A is diagonally dominant. So we observe, okay, let's say first row, 5. Okay. First 5 is greater than 1 plus 2. So this one make it become second row. So, observe that A11, 4 here is greater than 1 plus 2. So make it become first row. 4, 1, 2. Okay. 8 is greater than 1 plus K2. So this make it become third row. Okay. So now when you observe this value, 4 greater than 1 plus 2. 5 greater than 1 plus 2. 8 greater than 1, take magnitude 1 plus 2. So now this is diagonally dominant. Okay, example 4. Solve the system of linear equation below by the Gauss Seidel iteration method. Okay, 2, 8, negative 1. Negative 1, 1, 7, 5, negative 1, 1. Okay, this is our A, metric A. This is our vector X equal to vector B. Okay, first of all, make sure your metric A is diagonally dominant. Huh? Okay, observe here. 8 is greater than 2 plus 1. So this will be row 2. This is row 2. Okay, see, 7 is greater than, okay, this one take magnitude is 1 plus 1. So this is row 3. Okay, observe here. 5 is greater than 1 plus 1. So this will be row 1. So take out whole row. Okay, make sure you swap A together with B because these are the whole equation. Okay, so you swap it to become your system. First row is here. 5, negative 1, 1. So this is 11 here. Second row is 2, 8, negative 1, 17. Third row is negative 1, 1, 7, 21. We make sure B together because they are actually the whole row. 2, 8, negative 1, 17, second row. Negative 1, 1, 7, 21, third row. First row is 5, negative 1, 1, 11. So make sure first step swap row so that it satisfies, it becomes diagonally dominant. Okay, if the metric is not diagonally dominant, then wasting your time to do your table, the Gauss Seidel iteration method, you won't get the converged solution. So this is the system after we swap the row, make it become diagonally dominant. So now write down the Gauss Seidel iteration formula. So you write down x number 1. It will be like this. Here from the latest system after you sorting the row. So 11. Okay. Here x1, x2, x3. So you're going to solve for x1. So coefficient for x2, x3 bring to the other side, so it becomes plus x2 minus x3. Okay, divide by the coefficient of x1, which is 1. Later on here, we put k. This is k, where the k start from 0, 1, 2, and so on. Okay, this will be x1 at k plus 1. And when k is 0, you get x1 at step number 1. Okay, and then you calculate x2. Okay, x2 here, so from the second row, you obtain the x2 formula. So it will be 17. Coefficient for x1 bring to the other side become minus 2 x1. Okay, this negative 1 bring to right hand side become plus x3. Divide by coefficient for x2, which is 8. Okay, x2, k plus 1. Huh? x3 is still O1. Okay, x1 here. Okay. So x1 will be k plus 1. Okay, now to calculate x3. Focus on x3. Okay, the other, okay, x1, x2 bring to the other side. So you have 21 plus Also minus 1 bring to right hand side become plus x1. Okay, here bring to the other side, so become minus x2. Right, again. So x1 k plus 1 x1. So 11 plus, this is x1, x2, x3. So plus x2 minus x1 divided by 5. This is k, this is k. So the k start from 0, 1, 2, and so on. Okay, and then go to calculate x2. Okay, x2 here. So 17. Positive 2 bring to the other side, so minus 2 x1. Okay, negative 1 x3 bring to the other side, so become plus x3. Okay. And divide by coefficient of x2, which is 8. Okay. So x3 instead have only O1. x1, we have the latest one. So x1, k plus 1. Take the latest x1 value. So you can get the latest x2 value. Okay, now go to calculate x3. So x3, 21. Here, minus 1 bring to the other side, so plus x1. So here 1 x2 bring to the other side become minus x2. So divided by coefficient of x3, which is 7. Okay, x1, x2, we have the latest value. So x1, k plus 1. x2 also got the latest value, so it's k plus 1. Then I can get the latest x3 value. Okay, this is a Gauss Seidel iteration formula. Okay, and then I will put into the calculator as they represent x1 using a. So a equal to 11. x2, then this one represent using a. This represent using b. x3 represent using c. So 11 plus. Okay. So in calculator we don't care is step k or k plus 1. x2 is b. x1 this is x3. So x3 is c. Divide by 1. Then you put the column. Okay, you can get the column K from the calculator. So b equal 17 minus 2. Okay, x1 a plus x3 is c divided by 8. C equal to 21 plus x1 is a, x2 is b, divide by 7. Then you input this formula into your calculator. Okay, in one line, and you press calculate. Okay, they will ask you A is what? You key in 0. Sorry, they ask you B first. Sorry. Let's say for B first. They ask you B. So we key in 0. Then later on they will ask you C. You key in 0. So you put 0. So B and C, 0. You get 11.5. This value will be stored in A. Okay. And then this is a simultaneous equation. So the A value later on, put it here. Then C still 0. So the A value which is kept in the memory in variable A, you put it here. C still O value. So you get the B. Okay, once the B value, you plug in here. A value plug in here, you get C. Okay, so you just key in B0, C0. Okay, B0, C0, you obtain A. A value is automatically substituted in the B formula together with the previously key in value of C, you get B. So B will be automatically plug in here, and A, plug in the C formula, you obtain the C. So you get the x1, x2, x3 at iteration 1. And then when you press equal again, okay, the B, which is here, B is actually the latest x1 value. C is the latest x2 value. It's there already. So we put it into A. So the process is repeated until the conversion criteria is satisfied. Then you can stop. The last row will be your solution. So you need to use a calculator. Take the calculator. So I'll show you using calculator later on. I'll show you using the Excel. So in the calculation mode, which is mode number 1, so I input alpha A. The equal is a red color equal. Alpha equal. Put this fraction form. 11 plus B minus C divided 5. Okay, column, right here. So alpha with column, alpha B, alpha equal here. Okay, B is actually 17 minus 2. Okay, this is A. Okay, this is C. Divide 8. Then column, alpha C, alpha equal, C is 21 plus A minus alpha B divided by 7. Check out the formula. C is 21 plus A minus B divided by 7. Okay, B is 17 minus 2A plus C divided by 8. A is 11 plus B minus C divided by 5. So I'm going to calculate. Okay, initially I put B 0, C 0. So I get A 11, okay, 2.2. So initially 0, 0, 0. So on 1, A is x1, 2.2. This is A, B, C. Okay, you equal. Automatically you get a B, 1.5750. Equal C, 3.0893. Then you check it. Then row 1 and row 0 of course greater than epsilon, so you proceed to row number 2. So now you equal. Okay, this is actually this value. Then equal more and more time. This is actually straight away you get this is the A, 1.8971. So equal. Then I equal now. I will get B, 2.0369. Equal. Get C, 2.9800. Okay, also okay, iteration 2 compared with iteration 1, okay, still greater than epsilon. Normally when you reach the solution, okay, they only differ at the last digit, which is less than 5 unit there. So you proceed iteration 3. This is a B value, this is a C value. You accept it just equal. Now A, you get that 2.0114. 2.0114 equal, you get P 1.9947. C 3.0024. Checking also the value differ okay so much. Proceed to number 4. 1.9985. 2.007. C 2.9997. So the value, okay, observe still very big. So we proceed to iteration 5. See, this is the C value. A 2.002. B 1.9999. C is 3. Okay. So you see the value now is closer, but still greater than epsilon. So I proceed one more step. So this is a C value. So now A, I get 2. B, 2. C, 3. So when you see each of it, okay, means here, when you check the epsilon for each one, each of it, okay, in the X number 6 means magnitude X at step 6 minus X at step number 5. Here you have 3 value, which is 0.0002. Okay, this is 0.0001. This is 0. Okay, it will take the maximum, maximum value of the magnitude X number 6. This is vector. So you have 3 value. Okay, the maximum value is actually maximum of this. Exactly 0.0002 less than the epsilon. Okay, for 4 decimal place calculation, 0.0005. Okay, then you can stop and the iteration is okay. So then okay, the solution is X number 6. 6, which is 2, 2, 3 transpose, not comma. The previous slide, the comma is wrong. Okay, X suppose is column vector. To save space, we make it become row. That's why this is transpose. So the solution is 2, 2, 3. 2, 2, 3. Okay, this is what I mean the error. Okay, this one is calculate the magnitude, the maximum magnitude. Okay, then I will show you if we use Microsoft Excel. Copy the version. So this is okay. 5, negative 1, 1, 1, 2, 8, negative 1, 7. negative 1, 17, negative 1, 1, 7, 21. Okay, after we arrange it so that it is diagonally dominant, okay, now I'm going to solve. This is a k, this is a x1, this is x2, this is x3. Initially 0. Initially 1. So we put in the formula in Excel. So we have the 11 minus, from here, 11, and then we want to put the formula for x number 1. So we have 11, this is minus 1, bring to the other side, plus 1 x2. Come plus, okay, 1 x2 here. Okay, this is minus 1 x3. Okay. Divide coefficient of x1, which is 5. So you get 2.2. Okay, from the second equation, after you arrange it, become diagonally dominant. So 17 minus 2 times, because coefficient of x1 is 2 times. Okay, x1 take the latest one. So this is what I mean, x1 step k plus 1. If you take this value, then this is x1 at step k. And then second equation, coefficient for x3 is negative 1, bring to right hand side, become plus 1 times x3. x3 will have only O1, so click the O x3. Divide by coefficient of x2, which is 8. Okay, and then x3 equal, which should bracket. Okay, B3 is 21. 21. Okay, coefficient for x1 is negative 1, bring to the other side, plus 1 times x1. Okay, x1, you have a, okay, O, and this is O, this new, take the new one. Okay, coefficient for x1, this is 1 times x1, bring to the other side, minus. So minus x2. Okay, x2, now you have the latest one, take the latest one. Okay. Divide by coefficient of x3, which is 7. Okay, so now you can copy down the formula as many as you like. Here we at step 7. You can see there's no more changes. Or you want to calculate the errors. You can have actually 3 errors here. Error 1, error 2, error 3. The error is actually absolute values of ABS. ABS, the new x1 minus a previous x1. Then I can copy the formula. First, you see. So Excel not only you copy it down, you can copy it across column also. The pattern will be followed. So you see the errors greater than epsilon, that's why I proceed to the next row. And then if you use, let's say, here I didn't round. So let's say I just, I did round is better, I just reduce. This one is didn't round actually for display purpose, it display up to 4 decimal place. So we will use this one. So if we use K here, then when you see the error, the maximum one, this one is a 0.002. When you stop at number 6, so your x1 is 2, x2 is 2, x3 is 3. This is step 6. Just now, but one step. Also step 6. Step 6. So your result is x at the step 6. So, but if you use Excel, it will be much faster. Well, you just key in the first, in the formula at step 1, you can just drag down and you can calculate the errors quickly. So how you key in the formula is similar to in the slide here. Without the formula here. The same way you put out the formula only in Excel, make sure, because it cannot in natural display like in your calculator. So you make sure the numerator 3-term bracket. Then you need, okay, in the new row to calculate x1, you key in equal, okay, bracket 11 plus, okay, x2k is actually click the O x2 here, the O x3, which is 0, 0 there. Then divide is backslash, divide by 5. Okay, E, show bracket, equal 17 minus 2 x1k plus 1. So you click the new x1. Okay, only multiply in Excel, start. x3 is still only O1, so click location of O1, divide by 8, divide backslash. Okay, then go to the x3, in this formula, 21 plus x1, click the location of the new x1, you have the new x2, click the new x2, divide by 7. Okay, and then once the formula is keyed in correctly, so you can see initially x1 at step 1, x2, x3 is a O1. You see x2, since you have the new x1, so click the new x1, x3 still O. Okay, and then the x3, okay, you see x3, x1, x2, the same row, because you got the latest, okay, x1, x2. Okay, after that, select the whole row. Okay, if you key in the arrow formula, so you can select together the whole row, just copy down. So I think we stop at iteration 6. Well, the maximum error is 0.002. Okay, less than epsilon 0.005. Then the answer is x number 6. Vector x number 6 consists of 2, 2, 3. Okay, so with this, I think we expect the formula. With the Gauss Seidel iterative method, make sure A is diagonally dominant. So mean magnitude AI must be greater than summation of the other two magnitude entry at the same rows. And then from that, after you arrange it diagonally dominant, so get back the x1, x2, x3 formula. Okay, k in the O, k plus 1, the new k value. Start with the initial guess. Here no, this is in the. So until the maximum of the magnitude xk plus 1 minus xk less than epsilon is satisfied. So with this, thank you for your attention.